Picture this. You're standing under a velvet night sky, stars sparkling like a million tiny dreams. Have you ever wondered if we could actually reach them? That idea feels like it's been part of us forever, but it's actually pretty new. Let's dive into the moment humanity first realized just how vast the universe is. Back in 1838, a German astronomer named Friedrich Bessel did something groundbreaking. He measured the distance to a star, 61 Cygni. For the first time, we understood the jaw-dropping scale of the cosmos. Those weren't just pretty lights up there. They were worlds separated by distances that boggle the mind. But instead of feeling overwhelmed, we got curious. That's when the dream of exploring other planets took root, and it's only grown stronger. With Earth's resources dwindling and tech racing forward, the stars feel closer than ever. But man, are they still far. So, how do we even start chasing this dream? Let's talk about the game changer that got everyone buzzing. Okay, here's where things get exciting. Proxima b. In 2016, astronomers found something incredible. An Earth-sized planet orbiting Proxima Centauri, the closest star to our Sun, at just 4.24 light-years away. Most of the 5000+ exoplanets we know about are hundreds or thousands of light-years out. But Proxima b? It's like the neighbor next door in cosmic terms. This planet hangs out in the habitable zone of its red dwarf star, where liquid water, and maybe even life, could exist. It's not just a dot in the sky. It's a destination that's got scientists dreaming big. But getting there? That's a whole different beast. Let's unpack why this trip is so tough. Now, let's get into the real challenge: distance. Proxima Centauri is part of the Alpha Centauri system, a trio of stars. Proxima b orbits its star at just 0.049 astronomical units, 20 times closer than Earth is to the Sun, but it's still in that sweet spot where life might be possible. Here's the problem. 4.24 light-years is about 40 trillion kilometers. Our fastest spacecraft, New Horizons, zips along at 59,000 kilometers per hour, but even at that speed, it'd take 78,000 years to reach Proxima b. To make it in, say, 20 years, we'd need to hit 28% the speed of light, 300 million kilometers per hour. That's not just a tech upgrade. It's like rewriting the rules of physics. So, what wild ideas have we come up with to tackle this? Let's explore some of the craziest ones. Speaking of wild ideas, let's rewind to the 1960s when scientists were thinking way outside the box. Ever heard of Project Orion? They wanted to propel a spacecraft with nuclear explosions. Seriously, detonate small atomic bombs behind the ship, letting the shock waves push it forward. It sounds nuts, but made sense on paper. Physicist Freeman Dyson even suggested using fusion bombs for interstellar trips. Too bad setting off nukes in space freaked people out, so it got shelved. Then there was the Bussard ramjet, a sci-fi dream where a ship scoops up interstellar hydrogen with a giant magnetic funnel, fusing it for thrust. No fuel to carry, just use what the universe provides. The problem? Space is basically empty, with just one hydrogen atom per cubic centimeter. You need a funnel thousands of kilometers wide, and it still wouldn't cut it. These ideas didn't work out, but they lit a fire under our imaginations. Let's check out some plans that got a bit closer to reality. Here's where things start feeling more doable. The 1970s brought Project Daedalus. The British Interplanetary Society designed an unmanned probe that would use controlled fusion microexplosions, fueled by deuterium and helium-3, to hit 10% the speed of light. This 50,000-ton monster, mostly fuel, could reach Proxima Centauri in about 36 years, snapping photos and beaming data back to Earth. It was a one-way trip, but it showed we might actually pull this off someday. Then, in the 1980s, we got laser sails. Picture a 6-kilometer wide, 30-gram sail pushed by a laser beam from Earth. The light's pressure could get it to 20% the speed of light, reaching Alpha Centauri in just 21 years. The catch? No way to slow down, you just zoom past. Still, sailing on light is pretty darn cool. Let's push the limits even further now. Want to talk about the ultimate power source? Let's look at antimatter. 1 gram of antimatter, when it meets matter, releases 70 times more energy than nuclear fusion and 4 billion times more than burning oil. With antimatter propulsion, we could hit 40% the speed of light, getting to Proxima b in just over a decade. Sounds like the answer, right? Not so fast. We can only make tiny bits of antimatter in particle accelerators, and producing 1 gram would take billions of years and more energy than all of Earth's power plants combined. It's the stuff of dreams, but we're not there yet. So, what's NASA cooking up to make this happen? Let's find out. Here's the big plan. NASA is eyeing a mission to Proxima b by 2069, time to celebrate the 100th anniversary of the moon landing. They want a probe that can hit 10% the speed of light, reaching Proxima Centauri in a few decades. This isn't just about a faster ship. It's about rethinking propulsion, energy, everything. We send tiny AI probes, self-replicating machines, something totally new. We're still figuring it out, but think about this. A century ago, we barely had airplanes. By 1969, we were on the moon. What could 2069 bring? Let's talk about what it'd take to send humans on this journey. Now, let's get personal. Could we go to Proxima b? Sending humans is a massive leap from probes. The energy, life support, and sheer scale are mind-boggling. One idea is the interstellar arc, a floating city in space, carrying generations of humans, animals, and plants in a self-sustaining ecosystem. It could travel for thousands of years, but who'd sign up for a trip they'd never see the end of? Maybe people escaping a collapsing Earth, or those driven by pure adventure. But biotech could shake things up. What if we could extend life, slow metabolism, or send digital versions of ourselves? Our creations, smart probes, or nanobots, might get there first, paving the way. Let's explore why this whole crazy idea matters. Why even bother with a destination so far away? That's what's on my mind now. Reaching Proxima b isn't just about landing on a planet. It's about who we are as a species. It's about answering the big questions. Is there life out there? Can we find new homes? Can we do the impossible? Proxima b is the closest stepping stone, a symbol of what's possible. Every step toward it changes how we see ourselves in the universe. Our machines, our ideas, or maybe our descendants could be the first to arrive, carrying our dreams to the stars. So, here's the thing. The journey to Proxima b starts right now. It's not just about building better tech, it's about dreaming bigger. Every wild idea, from nuclear bombs to laser sails, pushes us closer. Every failure teaches us something. And every spark of curiosity keeps us going. Will we see Proxima b ourselves? Maybe not, but we could be the ones who make it possible, or the ones who take that first cosmic leap. The universe is out there, waiting for us to take the next step.